In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. It's perhaps the holy grail of planetary science.
Are we alone in the universe? It's one of the grandest questions we could answer.
We don't really have a definition of life, but I think I'll know it when I discover it.
Life can take many twists and turns, and I think the really cool thing about it is the variety that we're going to be able to find elsewhere.
Are we a lonely planet? Or does life exist beyond Earth? Members of the groundbreaking field of astrobiology have joined forces to solve this enduring mystery. Life. Is it rare in our universe? Or is space a galactic zoo, teeming with all sorts of creatures?
Everybody has this sort of iconic view of the aliens. They're going to be little gray guys with big eyeballs and small noses. Well, maybe, but I don't think so.
On far-off planets, life may be as far out as buggy-eyed microbes or sci-fi sea monsters like galactic manta rays. Others may be home to cybernetic organisms, hybrids of biology and machines.
One way to get a handle on thinking about super advanced aliens is to try to imagine the possibilities of our own future. Maybe it'll be machine-enabled humans. I feel like I've already become a machine-human hybrid. I mean, I have this laptop computer that I take with me everywhere, which is really kind of the third hemisphere of my brain. My body's even changing and becoming sort of shaped like a person using a laptop computer, and so I'm becoming Homo laptopicus. It's likely that the universe is full of life. We don't have evidence yet that we're not alone. So we're out there and we're looking.
When it comes to hunting for alien life, planetary scientist and musician David Grinspoon walks to a different beat.
I do wonder, in terms of extraterrestrial life, whether they'll have music or something like music. Music is fundamentally waves and rhythms, and that's sort of the nature of our universe. There is a certain musicality of just the fact that it's all vibrations and waves and rhythms and modulated tones. So I can imagine, and this is just my wild fantasy, some analogy to world music far in the future where we're mixing our musical cultures with alien musical cultures. I think you'll get many different shades of astrobiology if you talk to different scientists, but I think you'll get a lot of agreement on the broad goals. We want to find life elsewhere, but in the meantime, we're learning a lot about the history of life on Earth.
In the field of astrobiology, one of the fundamental goals in searching for life elsewhere is first figuring out how life evolved here on Earth.
One of the big unsolved mysteries in astrobiology, of course, is how life got started on Earth. Because if we could understand that, then we would have some insight into whether it could have gotten started elsewhere.
Earth orbits in what's called the habitable zone. It's a region of space where conditions are favorable for life forms that we know can be found on our planet. We are at just the right distance from the sun, so our oceans don't evaporate. Our temperatures are not too hot or too cold. And we have oxygen in our atmosphere, so we can breathe. Earth's been a cosmic paradise for all types of life, from small single-celled organisms such as bacteria to large multicellular mammals, including man.
It's believed that all life on our planet descended from a single common microbial ancestry, approximately 3.4 to 3.8 billion years ago. But how that microbe came into being remains puzzling. One way to search for answers is to look for ancient rocks, where microbes leave trace evidence of their existence.
Geology is a crucial tool for understanding the origins and evolution of life on Earth, because the historical record of life on Earth is almost entirely recorded in the rocks that we walk on.
Geologist Abigail Allwood's journey to discover the origins of life took her no farther than her own backyard. The Pilbara region of West Australia contains some of the oldest rocks on our planet. They're almost 3.5 billion years old.
The Pilbara contains rocks from the early Archean era that have survived on the Earth today. They contain several rock units that contain possible evidence for life.
Planet Earth has been around for over 4.6 billion years. But most of its original surface has been obliterated by plate tectonics and erosion. The extremely thick crust in the Pilbara has helped it resist destructive geologic processes.
The Pilbara hasn't been strongly affected by plate tectonics, and the original features in the sedimentary rocks are more or less ready for us to interpret. There are also sedimentary rocks of similar age, almost 3.5 billion years old, in South Africa. So far, the Pilbara seems to have yielded a richer fossil record.
Allwood spent more than 3 years surveying some of the rock formations in the Pilbara, examining unusual structures called stromatolites, fossils formed by living organisms 3.5 billion years ago.
We realised that what we were looking at was the remnants of an ancient reef, a microbial reef. It's not a reef made of coral like we're familiar with today, but a reef made of stromatolites, structures formed by microorganisms.
Stromatolites are rocky structures that form on the sea floor, where fine layers of sediment are built up into cones, domes, and other shapes over a long time with the help of tiny organisms. A stromatolite is not alive, but is a structure made by living things. When we find one in the fossil record, it is like finding the footprint of long-dead microorganisms. But the microbes themselves are almost never preserved as fossils inside the stromatolites. And without that, it is extremely difficult to be sure an ancient stromatolite is proof of life. But in this case, Allwood found that the Pilbara stromatolites are in fact biological. She just may have discovered the oldest evidence of life on our planet.
These stromatolites are the oldest convincing evidence of life on Earth, and these amazing pronounced conical structures that are not like any kind of wave ripple or a structure that you'd expect to see